Hi, myself Vaishnavi, Assistant Professor in the Department of Information Technology from SNS College of Engineering. Now let us see about the second normal form. The table must be in first normal form and it satisfies some conditions similar to that to be in a second normal form. It asks that what are those, let us see. First condition is that the table must be in first normal form, as it cannot be in the second normal form if it is not in the first normal form. So the logical is that, and the second condition is the table must not have any partial dependency present in it. So if these two conditions are satisfied, then a table or a relation we can say state that the table is in second normal form. Now let us see with some examples for the better understanding. So let us use both conditions one by one. First condition is the table or relation must be in a first normal form. Two conditions for first normal form are no multivalue attributes, no composite attributes. Since we all know about the meaning of multivalue attributes and composite attributes, so the table is in first normal form or not. Let us check it. If it is not in first normal form, then it cannot be a value. So here the mobile number is multivalue attribute. It has two values for each tuple, so it is not in first normal form. If we modify this table into this, it can be in a first normal form because each column is single valid attributes. Let us take another example. In this table, first normal form answer is no because course attribute is multiple values. So when we solve this into the following changes, then the table can say it in a first normal form. So the following table, it does not have any multivalue attributes. Is it in first normal form? And if again, is it in first normal form? No, because it does not contain multivalue attribute, but it contains attributes name, a composite attribute which can be further divided. So again, this is not in first normal form. We can modify it like this: first name and last name. Consider this table and check if it is in first normal form. Not in first normal form. You must have guessed it. Yes, it is not in normal form because it contains composite attributes, that is others can be divided into further. So to make it into first normal form, we can modify it like this. So let us take one last example, whether this table is in first normal form, as it has no composite and no multivalue attribute present in it. So hope you understand the first condition for the table to be in second normal form. Second condition is there must not be any partial dependency. So let us understand this with an example. In this table, to check whether there is a partial dependency, a table first thing you need to identify is candidate key. In this table, just by using student ID, can we identify the complete tuple? No, there is redundancy present in it. Similarly, using course ID, we cannot identify complete tuple. It has also have redundancies. Same is the condition with the course fee. So if you look up closely, by using student ID and course ID, we can identify the complete double, that is student ID and course ID closure will give us values of all attributes. So we can conclude that student ID and course ID together form a candidate key. There is only one candidate key in this table. Next step is to differentiate prime attributes and non-prime attributes. Prime attributes are attributes present in the candidate key, in our case student ID and course ID. Remaining all attributes which are not part of candidate key or a candidate keys or non-prime attributes. In this case, course is non-prime attribute. So partial dependency definition is states that if a non-prime attribute is determined by a part of a candidate key, that functional dependency is a partial dependency. Let us check student ID and course ID determines course fee. Course fee is one of the functional dependencies. In this case, complete candidate key determines a non-prime attribute. Other than if you see by using course ID, we can uniquely identify course fee. So this can also be a functional dependency. Now, in this case, a non-prime attribute course fee is determined by a part of a candidate key, that is course ID. So this functional dependency over here is a partial dependency. While this is present in a table, cannot be here in the second normal form. So we found a partial dependency in this table. To eliminate this partial dependency, we split this one table into two. What does eliminating partial dependency does? So this tries to reduce the redundant data from getting stored in a memory. So imagine there are thousands of students and records of these students are stored. Course fee is same for a particular course ID, but it will get stored thousands of times due to partial dependency. So this elimination of redundancy is the aim of second normal form. So table should be in first normal form and table must not contain any partial dependency. So we can say that the table is in second normal form. So this is all about second normal form.